I am Gayatri, working as assistant professor in EC department at Sns College of Technology. Today I am going to discuss about the topic gradient, which was studied in first unit electrostatics by the second year students for the subject electromagnetic fields and waves. Before going to the discussion of the topic gradient, we have to recall the topic the electromagnetics, how the coordinate system is related to the electromagnetics and how the position is located by using the coordinate system. The basic coordinate system, which is classified into three types, which is Cartesian, spherical and cylindrical coordinate system. For making the calculations of antenna and for locating the antenna position, we can use our coordinate system, as well as the scalar quantity and vector quantity is also used in our electromagnetics. The vector quantity, which is represented with the help of magnitude as well as direction. And coming to the topic of discussion, today I am going to discuss about the gradient of concept and what are the roles of electric and magnetic field in the place of gradient function. And last we are going to discuss about the real-time application related to that, the gradient. And the empathize part, the need of the gradient, which is the electromagnetic field. We know that already it is the combinations of electric field and magnetic field, and the field will be varying with respect to the position as well as distance and with respect to the time. And mathematical tool which is used to related to our field variations to describe the field variation. The gradient, which is nothing but it is a scalar function. How the scalar function is related with the help of gradient. Next we are going to describe about the gradient function. The gradient will be represented with the help of vector operator, which is del. Del, which is the operation of vector operator with the help of grade scalar function, is called the gradient of scalar, and which indicates the direction of maximum increasing, and which is the rate of change of scalar function related to that gradient. And the definition part of the gradient, which is the scalar function, which is represented by W. The W, which is related to the Cartesian system x and y and z, where the W of x comma y comma z, which is a scalar function which is related with help of del operator, where del, which represents dou by dou x of ax vector plus dou by dou y of ay vector and dou by dou z, and it is multiplied with the scalar function. Then del W, which can be related as del W by del W, which is related by dou W by dou X plus dou W by dou Y plus dou W by dou Z. And the result of the scalar gradient of scalar is the vector quantity, and it is unit depends upon only the scalar functions. And coming to the gradient of scalar potential, the scalar potential, which is nothing but it is a scalar field, and it is related by with the help of using gradient function. Then the electric field is related to that E vector, which is equal to minus del V, where the negative sign which represents the negative direction, where it is a decreasing potential. This how the gradient and electric field is related. E vector, which is equal to minus del V. And coming to the significance of gradient in electromagnetic field, the gradient which is used to describe the directions where the potential, how the potential is increasing and how the potential is decreasing, and magnitude, which represents the rate of change of a potential with respect to distance. And the electric field line, it is always perpendicular to our potential surfaces, and it is the gradient which helps to visualize how the electric field pattern is distributed among the whole surfaces. And coming to the gradient in different coordinate system, we know that we are having the three coordinate system: Cartesian, cylindrical and spherical. In Cartesian, it is represented by x, y and z. In cylindrical, it is represented by r, phi and z, and spherical, it is represented by r, theta and phi. Depending upon the gradient position, gradient, we can locate our exact position of particular object in our space, and it is used depend upon the geometry of electromagnetic problems related to that. And coming to the real-time applications of gradient, we can use for the electric field distribution, and also in transmission line as well as in field distribution we can use this gradient function, and also in Gauss law and capacity analysis and Coulomb's law we can use our gradient, and it is mostly helpful in electric potential, and the gradient relation can be related with the help of this gradient function. Uh, Let us summarize the topic what we have discussed. Gradient, and what are the concept, and what is the relation between electric field, and what is the coordinate system, and what is the applications of electromagnetic field in gradients. Okay, these are the references we had taken for the gradient of scalar. Thank you.